The IMLN function within Excel allows us to calculate the natural logarithm of a complex number. In column A, I have some complex numbers consisting both of a real and an imaginary part. Now, all we have to do is write equal sign IMLN and then provide as the only argument a complex number. Now, do keep in mind that complex numbers are considered text or strings within Excel, and so that's why we need a special function within Excel, which is the IMLN function, and we cannot use a regular ln function to take the natural logarithm of this complex number. I close the parentheses, press enter, and pull this downwards. I'll also extend the width of this column. So there we have it. That's a result of taking the natural logarithm of a complex number. Now let's take a look as to how this natural logarithm of this complex number was actually calculated. Now, in order to do this, it's best to transform our complex number from the rectangle form to the exponential form. In column A, we have the rectangle form, where we have a real and an imaginary part. And using those two parts, we can plot our complex number on the complex plane. The real part is associated with the x-axis and the imaginary part is associated with the y-axis. So that creates a coordinate that allows us to plot this. Now, there's also a different way of how we could uniquely identify a complex number on the complex plane. We do this by first taking the distance from the center of the complex plane up until the complex number. That will give us a circle around the center, and then to specify the point on the circle we are looking to take, we define an angle that we want to take from the x-axis up until the point. So for this, we need to calculate two variables. The first one is r, which we also call the modulus, or the distance from the center to the point. Now this is calculated by squaring the x-coordinate, adding the square of the y-coordinate, and then taking the square root of this. This is derived from the Pythagorean theorem. Fortunately for us, there is a simple to use Excel function to calculate this for us. And this is the MABS function, which will return the absolute value of a complex number, which is equal to the modulus of that complex number. So as the only argument, we supply the complex number, I press enter, and I pull this downwards. So there we have the distance from the center of the complex plane up until our complex number. Now we need to calculate theta, which is the angle at which the point is situated from the x-axis. This is calculated using the tangent. Fortunately for us, there's also a simple to use Excel function to calculate theta. Now we can do this with the m-argument function. Now the m-argument will return the angle at which the point is situated in radians. Once again, we only have one argument and we supply the complex number. I close the parentheses and I pull this downwards. Now, using this information, we can reconstruct our complex number in the exponential form. And so the exponential form is r times e to the power theta I. Okay, so first let's take r, which is the distance from the center to our point, and I will be rounding this value down to 2 digits. I can do this with the round function. Now, I will be concatenating this as strings. So I use an ampersand to concatenate two strings together, and then I take e to the power of theta. Now I write e to the power, and that's a string, and then I concatenate this with the theta rounded down to 2 digits as well. And then I concatenate this with an I. Just like that, I make sure to put I in between double quotation marks because this is text and not a number, at least in Excel. I press enter and I pull this downwards, and so there we have our exponential form of our complex number rounded to 2 digits. Okay, so now we want to take the natural logarithm of this number. Now, we didn't necessarily have to first convert it into the exponential form, but it does make things a lot easier. Because whenever we are taking a logarithm of a number, and that number consists out of a product, which is the case, in our case, it's r times e to the power theta I, we can actually split these two parts up, take their separate logarithm, and then add them together. So in our case, all we need to do is to take the natural logarithm of r, so we can do this with the ln function. Now, do keep in mind, we don't need the IMLN function, just a regular ln function, which will take the natural logarithm of a real number, which is the case with r. So I provide r, or the modulus, and I close the parentheses. Out comes the natural logarithm of r. Now we need to do the same thing for the next part, which is taking the natural logarithm of e to the power theta I. Now, a unique property of e, which is Euler's number and stands for 2.7, 18, 28, etc., and the natural logarithm is that they cancel each other out. So all I need to do is to reference theta, which we already calculated in column D, which is the angle at which the point is located. So now I can use the complex function to create a complex number using the real and the imaginary coefficients that we have calculated here. So I can use the complex function, so I type equal sign complex, and then I need to provide the real number, which is the ln of r, and then I provide the imaginary number, which is the ln of e to the power theta I. Now I close the parentheses, press enter, and I pull this downwards. I extend this, and as you can see, this matches exactly with the results we got back from the IMLN function. So that's actually what's going on if you want to manually calculate the natural logarithm of a complex number. You convert the complex number from its rectangle form into its exponential form by calculating the modulus and the argument. Then you split up your complex number in its modulus and its argument. You take the natural logarithm of both, and then you add them back together. And that will give you the natural logarithm of a complex number. So whenever you need to calculate a natural logarithm of a complex number in Excel, you can use the IMLN function, supplying the complex number to it, and out will come its natural logarithm. Thanks for subscribing and leaving an optional tip. Consider watching this video next.